Evening, sir.
Good morning. What's up?
Nothing much, sir. Well,
How are
just
you?
ready for. I'm ready. Okay, sir. You, sir?
Good, good.
Good.
All right. I don't know if you can touch base with them until well, let them say we still have 3 more minutes. I'm starting at 5 minutes past. I'm not giving more than 5 minutes because time is going. Did you do the homework, sir?
So you gave us homework?
Boy,
Oh, to find the
if I
things.
knock you out, you grow.
Uh, well,
Start the homework now.
okay, sir.
It's now it's now 5 minutes past 5 minutes past the hour, and I'm officially beginning my class. Um, Let me see a show of hands of those who completed my assignment, please. Anybody? Somebody? Am I being heard?
Yes, sir.
Mm-hmm. Just checking. I will answer question one more time. Let me see a show of hands of those who did my homework. Okay. Did anyone do my homework? Okay. All right. I'm not
Sir.
sending I'm not sending any notes tonight, you hear? Irrespective of what I use in class today, because I'm not sending it to you for safekeep. So when it's time for exam again, draw for them. It is to start the preparations from day one. So don't look for anything for tonight, you hear? I'm not rewarding bad behavior. Someone said, sir?
Good evening, sir. I just joined.
Yeah, man, Alvin, what going? You do my homework?
Yes, sir. I
You do my homework?
did some practices, but I didn't do the homework.
Okay.
Yes,
All
sir,
right,
but
let me go
yes,
ahead. Go ahead. You're understanding what to do?
yes, sir. Yes, sir. We did what went in class through in class the other day.
Mm-hmm.
Yes, sir.
All right, I'm giving you no more than 10 minutes to complete the question, please and thanks.
All right, sir. I'm joining on with my laptop now. This is my phone.
Okay, good. Are we finished, guys?
Not yet, sir.
All right. Let me know, please. Let me know. Let me know. If and fast, hurry up on me, please. 23 passed. Has anyone completed the assignment?
No, sir, I'm still
No,
working
sir.
on it.
All right, quick question. Does anyone in the class know what is required of them for the question?
Yes, sir.
Okay. So have you completed it now?
I think I'm on the last part.
Okay. Anybody else? I hear you, Jamal. Anybody else?
Yes, sir. May I try
Sir,
some?
I'm saying something in the chat now, sir. I don't know if you're right.
Okay.
I'll try, I think.
Sir, I'm lost. Which question?
And the homework question.
It's a homework question. I think you're in the group. So the last PDF, you can scroll all the way down to the bottom. You can see the homework.
All right. So I'm seeing those answers and they kind of look suspect. Mhm. All right, then let me know when you're finished and then I'll just go ahead. Because it appears that let's see, coming over here.
Wait, you say me?
Yeah, man. When you finish your question, just let me
Oh,
know,
finish,
please.
sir.
You finish?
Finish. Yes, sir.
What did you get for your answer?
0.77.
0.77?
Yes, sir.
Okay. You and Mr. Hamilton are singing the same tune. Read the question for me, please.
Right, sir. The question asks for given the equation x cube equal 2 minus 2x, show that the equation has a root in the interval 0 and 1, hence giving the root to 2 decimal places.
Okay. So how many decimal places? 2 decimal places? All right. All right. So yes, the pair of you are correct. The pair of you, yeah.
So we can quickly say something, sir.
Go ahead.
Me there, I did the wrong song for a long while until me realize so me did leave out something. That's why it did take me so long. Would have finished it quicker if me did just remember one song.
Okay, no problem. Um, I just need to say something. Um, I just need to say something, and it's just going to be a wholesale statement. If it applies to you, make the corrective action. If it doesn't, keep walking. So as I told you, I have completed the exam papers weeks ago. What is giving me a challenge now? I had a conversation with Mrs. Campbell today. What is giving me a challenge is the multiplicity of coursework pieces and quite a number of students, not calculus one, but the other course I was teaching. About half the class I didn't see for the semester. And their exam was first. I started marking their exam papers before yours. And I'm going through their coursework pieces. Though I saw it with yours as well. So in the era of AI and scanning a question and asking Google to help you, I am seeing all of that. I am a trained math teacher and I'm also trained in technology. And one of the things that in marking late last night, I just started awarding zeros. I just started awarding zeros because I don't know if students believe that the lecturers, well, sorry, let me go again. I don't know if students believe that Mr. Shand is a kunumunu and that I'm not going to be able to see it and that I don't have the requisite software in order to detect these things on my computer. Script after script after script after script. People think that, oh, I must get 100% on this because I answered them right. Wrong. I'm sorry. Wrong. Take me to court. I must win. Students, I'm saying to you, when you come to class, try and understand the stuff. Because when I give you your online, there's going to come a point, and I'm going to speak to my other members of the department that I'm in charge of. Because if the other members are seeing the same thing, I'm going to start calling students in for the mid-semester exams. If what I am seeing is widespread, I'm going to call students in for the mid-semester exams. It is embarrassing. So because of that, and each script now will have to be scrutinized and run, it is retarding the process. And I thought to myself, it's unfair for me to give up my weekend just to do this. It's unfair. So where people expect to get, and the final thing I'm going to say on this, because it's kind of, I will have one more thing to say after this. You know what is so ironic? The questions that were given for coursework and mid-semester, students getting full marks for it. Some of the rare questions came on the exam paper, and students struggled to get, if it's a 10 marker, struggle to get 3 marks out of the 10 on the exam. But for the mid-semester, full score. And that speaks volume as to exactly what is happening. So as it is just now, I am not pleased because this is taking longer than I expected. And it's simply because I have to be scrutinizing these papers. But I'm telling you one thing for sure, two things for certain. Don't think you're going to get 100% on these mid-semesters that you use AI to do. Negative, not with Mr. Shand. Maybe you can try it with somebody else. But for sure, I'm going to speak to my members of the department from foundation all the way up to calculus. And I'm going to say, if this is a common assault, we are calling students in for this semester for the mid-semester exam. You're going to do a paper-based exam. It is not right. And my final point on it is, if you come to class and you're using the same softwares to answer the questions and let me think that you are understanding, it's not helping you. It's not helping you. Way too many students get 80% for their coursework pieces and struggle to get 30% on an exam. Does not make any sense. It doesn't. The disparity is too wide. I am no kunomono. I went to good school. I am a trained math educator. It's not just somebody who can do maths and then say, sure, I'm going to teach a math course. I am a trained math educator, trained to see things and to make connections. And that's why I teach the way I teach. Just saying it. Big up on yourself. All right, so I'm going to project the solution that I did. Kind of a little disappointed that I had plans for today. It's now 18 minutes to 6. Had plans for today to move into something else, but I had to pivot to allow students to complete their homework. All right, things can happen. I give you a blight this time around. But for sure, if and when I share the documents with you, please just don't see the documents. Chances are I'm going to be including a question, even one question to it. All right. So let me go through this And I'm going to give you an opportunity to do yet another one for me, class. So the question says, for those of you who are not following or not understanding, I'm going to ask that you pay keen attention to what I'm doing here. So the question says, given the equation x cubed is equal to 2 minus 2x, show that the equation has a root in the interval 0, 1. Show that the equation has a root in the interval 0, 1. Hence, find the root to 2 decimal places. Find a root to 2 decimal places. So what it is that I'm saying is the solution to this question, the answer is going to lie between 0 and 1. Did anybody get that out of the question?
Repeat, sir.
Repeat, sir.
Now I'm saying to you, the solution to this equation, x cubed equal 2 minus 2x is going to be 0 point something. Anybody got
Yes,
that
sir.
from the question down?
Yes, sir.
Because the mere fact that it says it has a root, it has a root in the interval, meaning that it has a root there. That means one of the answers. Oh, by the way, let me answer a question because I don't want anybody. I want you to have a fulsome understanding to the areas that I'm teaching you, so that when the questions are given, you have no difficulty in dissecting them. How many solutions this question has?
So you mean like each one
How
of
many
them?
answers? How many possible answers
Oh.
can you get for this question?
3, sir.
2,
Why?
5.
Why?
Because it's a cubic equation.
Thank you very much, Rayton. So I'm expecting 3 solutions to this question because the order of this equation is 3. It is x cubed. So therefore, I must have 3 answers. No, the truth of the matter is 2 of the answers could be the same. All 3 answers could be the same. So if all 3 answers are the same, you can't say, sir, is just 1 answer. No, it will be thrice. And if it's 2 of the same answer, we have twice plus another answer. But you'll have 3 answers, which is why the question says, has a root. Has 1 root in this thing. So chances are, you may find another answer using another root. So if they did not give you an interval, it means that the answer that you got for this could be one of the roots that it has, and somebody could have found another root. So it is cubic. It has 3 roots. It has 3 roots. But this one in particular, by the way, anybody understand what I just said a while ago?
No,
Not
sir.
really, sir. Sir, how you get 5?
No,
Well,
the
I get
answer is
5.
3. The answer is 3, is not 5.
Yeah,
And the reason why it's
3.
3 is because it's x cubed. So
Did I say 5 at any point in time?
no, because what happens here is that when you were asking the question how many equations, someone said 3 and another person said 5. So
Oh, that's. I understand. I'm
So
sorry.
yes, sir. It depends on the
The
amount.
highest
Like, so
power
if you
in
have
the
x squared, I should get 2 equations.
Eureka. Yep.
Okay.
Yep. So if it's a linear equation, you have only 1 answer. If it is a quadratic equation, you have 2 answers. If it's a cubic equation, you have 3 answers. If it is a quartic equation, you have 4 answers, and so forth and so on. Yeah, man. I'll say it for a long time. Long time. Say it for a long time. Are you with me so far?
Yes, sir.
Are there any questions on that?
no, sir.
All right. So now, yeah, thanks, Tariq, because I really didn't hear the person that said 5. I know I heard Rachel that said 3. All right. So it says that it has a root between 0 and 1. Has a root between 0 and 1. So I expect my answer to be 0 point something. So the answer couldn't be 1. It could be, because 1 lies between 0 and 1. But it as long as it does not pass 1, and as long as the answer is not a negative value, because if the answer is negative, it means that it is outside of the interval. All right. And if the other root that you found is outside of the interval, you can't use that root. Why? Because it says in the interval 0, 1. So you have to be very specific with what it is that the with what it is that they're asking. All right. Now, so first thing I'm going to do is to rearrange. I'm going to rearrange. And in rearranging, I'm going to have, it's given me as x squared is equal to 2 minus 2x. I'm going to rearrange and put it in descending powers of x. I'm going to arrange it in descending powers of x. What do you mean by descending powers of x, sir? The x value is going to go down. X cubed, then the x, and then the x to the 0. So what I'm doing now is writing it in this way, and then, subtracting, and then I'm letting my f of x be equal to x cubed plus 2x minus 2. One of the first things you must do for the question, is to differentiate the function. Once you're talking about Newton-Raphson, and if you remember my introduction to the topic, I am guessing a point. The point that I guess, go ahead.
Where have to rearrange it, sir?
For your level, I would want you to rearrange it. For me, I could work with it as is. But for your level, until you are a little bit more mature mathematically, I am presenting the material in a manner that when you do the question, you're sure if you get it right. If you're given a quartic equation and you need to do, for example, a factorization, if it is not so arranged, you may miss one of the terms. So really and truly, mathematics is a studying of patterns. Everything that you do in math is pattern. So sequence it. And it's something that if you try it from early, you will be able to get it. So sequence it. You must do it. If you are mature mathematically, you don't have to. But if you're just learning this something, trust me. Follow my instructions. So when I get my f of x, go ahead. Go ahead.
The reason why me did arrange it because me decide to want it look like something I'm understanding or something I'm doing before. So that's why.
Absolutely. Oh, absolutely.
The way it look first, me I say, no, sir.
No, absolutely. Yeah, man. All right, let's go. So I have my f of x. I know I must differentiate because what it is that I'm doing is a topic on the applications of differentiation. It's a topic on the applications of differentiation. So it means that I must do some differentiation. I must differentiate something because I'm applying differentiation to solve something. So therefore, what it is that I'm doing here now is to differentiate x cubed plus 2x minus 2. The differential of a constant is 0. Differential of x of all of that now, my f dash of x is going to give me 3x squared plus 2. So I have this here. And then my first iteration, if they give me my upper and my lower limit, if I'm given my upper and my lower limit, it simply means that the upper limit and the lower limit will be added. The upper and the lower limit will be added and divided by 2. Because what it is that I'm finding again? Let me see if you remember.
First iteration.
Yeah, but
The root, sir.
Yeah, but that's not the word I'm looking for. In order for me to go for the first iteration, I must find something. What am I trying to find? There?
Interval.
Not interval I'm looking for. Come, I'm trying to find a what? How do I find the first iteration for this?
Oh,
The midpoint, sir.
The midpoint. The midpoint. Remember that.
Oh, yeah.
Remember that. I'm trying to find the midpoint. So all of the answers that I got is after doing the midpoint something. Yeah, I'm finding the first iteration. In order for me to find the first iteration, it is a midpoint that I'm using. Sir, so who was it? No, Carno, you are saying to me, sir, do I have to arrange it? I can say to you, Carno, that I could do this question without using
I was asking why you rearrange it.
yeah, man, I know your question. But I'm saying to you, I could do this question quick and fast without using 0.5. Right? And I would have still got my answer. But you know what the question says? To find the root to 2 decimal places. No, that's not what it says. Okay, this one didn't say it. Show that equation has a root. All right, this one didn't say it. But in order to put some, all right, put it this way. Some people making mac and cheese for argument's sake and boil the macaroni before they do the stuff. There are others who are making mac and cheese and just put the macaroni in there with enough liquid milk. And when they bake it, it comes out very good. The method that you use to cook curry chicken may differ. Some people decide that, yo, curry dangerous. I'm going to burn my curry because it tastes better. Others don't burn the curry, but it still come out very delicious. So I'm saying to you, there are different methodologies. However, when you're being coached on a particular methodology, for you to deviate too much from it may pose a little bit of problem. The point I'm making is we have to follow the instructions. We have to follow the instructions. Some of the questions will say by doing no more than 2 iterations. So if you don't follow the instructions and you use a different value, you're going to end up with more than 2 iterations in order to get to the end point. So therefore, you're going to be adding the lower bound to the upper bound. The lower bound is 0. The upper bound is 1. You're going to be adding those bounds and finding the midpoint, divided by 2. So you're going to you're starting midway. Starting midway, you can't go wrong. If you're supposed to go up, you're not too far off from it. If you're supposed to go down, you're not too far off from it. But if you go closer to 1, you may have a problem. Or you go closer to 0, you may have a problem. All right? So having differentiated the function, I'm finding the midpoint, my first iteration, and it's going to be equal to 0.5. Remember the formulation, x subscript n plus 1 is going to be equal to x subscript n minus f of n, x n, over the differential of x subscript n. So what it is that you're technically doing in layman's term is to use the first iteration. You're going to substitute the first iteration into the given function f of x. You put down that answer. You're going to also substitute the first iteration into the first differential. You put down that answer, and then you make a substitution into the formula. All right. So the first, you have the first iteration. The second iteration is going to know is what it is that you're trying to calculate. So you're going to start off with this formulation, x1. x1 is equals to f of x1 over f dash of x1. Let me caution you on something. I've seen 1 or 2 messages that say, sir, I was practicing XYZ. Sometimes you are practicing and the first iteration is x0. So you may go and you may see something that says x0, and x0 is really their first iteration. Now, when you are doing the calculation and you reach f1, do not get confused to say f1 is your is your first iteration. That will be your second iteration. So to be on the safe side, one of the things that I do so that students don't get confused is start my first iteration as x1. Some textbooks, some online lessons use the first iteration, their initial guess as x0. And let me tell you where that comes from. Anybody remember the day when the first case of COVID was identified in Jamaica? Anybody can remember where they were?
Yes, sir.
What did they call that case?
Don't remember, sir. I just remember where it was.
Patient 0, sir.
Patient 0. Patient 0. It's mathematics, you know. Mathematics. Patient 0. So when you see some of the questions talking about x0, it is really the first iteration they're talking about. It's really the first iteration. Patient 0, first iteration. So don't get confused. The methodology that your teacher will be using is to call the first iteration x1, second iteration x2, third iteration x3. But if you are following something from any other source and you see they use x0, x0, that x0 is representing the first iteration. And x1 is not representing the first, but the iteration after the first one, which is the second iteration. Please. So what I'm doing here is finding my x2, my second iteration is going to be my first iteration minus the fractional part of substituting the first iteration into the original function divided by the substitution of the first iteration into the differential of the function. So f of 0.5 is going to be anywhere in f of x, I see x, I put 0.5. So it's going to be f of 0.5 is going to be 0.5 cubed plus 2 times 0.5 minus 2, and I get 0.875, negative 0.875. I would have done a similar substitution using f dash of x to be equal to 3x squared plus 2, and then f dash of 0.5 is going to be 3 times 0.5 squared plus 2, and my result will be 2.75. So what I'm going to have now is 0.5 minus negative 0.875 divided by 2.75. Now, hear me out. Some of you students don't have respect for them signs here. They're called negatives. Please, if you ignore it, you're going to get the question wrong. If you divide two negative numbers, your result is going to be positive. If you multiply two negative numbers, your result will be positive. So these two numbers will be multiplied technically. So my result here is going to be a positive result. When I do this calculation, I'm going to end up with a 0.8181. Now, the truth is, the value after the first iteration is 0.8181. We can't say that is it. Why, sir? Let me ask you, why can't I say I've reached my endpoint?
Sir, because this is the first one you do. That is not a good explanation, but this is the first one. So you need to check it to make sure that once it repeats, the same answer repeats.
Thank you very much.
You know that you're good answer.
Thank you very much. So now you've answered my question. So it's not only that is the first iteration, because the second iteration. So I could do the second iteration and reach my endpoint the more. But how I know that I reach my endpoint is once I have a repetition of the calculation. I have not had a repetition. I was at 0.5, and then I jump all the way up to 0.81. No, man. Or 0.82, because I said two decimal places. 0.82. That's too big a jump. Follow me, class?
Yes, sir.
Yes, sir.
Good. So it means without anybody asking you, you must go through another iteration. You must go through another iteration. So therefore, I'm going to find x3. X3 is the same thing as repeating all of this. I'm repeating all of this with the exception, or the difference now, is that instead of using my x1 value, which is 0.5, I'm going to be using my x2 value, which is 0.8181. So I can round off right here, so no. You have to use those decimal places. You know why? Because if you round off, it is going to distort your answer. It's going to distort your answer. I'm giving it
more decimal places, the closer you get to the answer.
Very good, sir. Very good. I'm giving you the nuances in one, is a one-stop shop, so that when you are doing the actual questions, you're not finding yourselves into difficulty. All right? And remember, I'm going through this painstakingly because I'm going to project another question that I want you to do for me. All right. So I'm going to find x3, which is my third iteration. So my x3, all I'm doing, my x3 is going to be equal to x2. When I was finding my x2, I use x1 right here, x1 right here, and x1 right here. Now I'm finding my x3. I'm going to use x2 here, x2, x2. If I'm finding x4, I'm going to use x3, x3, x3. Anything we use right here, so is it going to substitute into here, so, and down in here, so. All right. So I'm finding my x3. So this is it. 0.8181 minus f of 0.8181 all over f dash of 0.8181. You are going to be Okay. So you're going to put in your calculators. Zero 0.8181 cube plus 2 times 0.8181. Use up your parentheses so that you can just plug everything one shot. Don't evaluate 0.81 cube and write down the answer. Put everything one shot in your calculator. Saves time. 0.8181 cube plus 2 open bracket 0.8181 close bracket minus 2, and you should get 0.1837.
Sir.
Yes, sir.
Remember last time you told us I get fraction calculator. I think
Right.
I'm find the button and change it to decimal.
Good job. Good job. Excellent. And then I'm going to do a similar calculation for my first derivative. I am substituting 0.8181 into my differential, and my result is going to be 4.0079. Combining those answers is going to give me 0.7723. This system is behaving very erratic. Why, sir? I started off with 0.5, then I jumped to 0.8181, and now I'm gone back down to 0.7723. Can I stop now?
No, sir.
No, sir.
I can't. None at all, I can't. There's no consistency in my answers. It says the two decimal places. One is 0.50, 0.82, and 0.77. Can't. Must do a fourth iteration. I have not yet found the root of the equation. I have not yet found the root of the equation. So I'm doing a fourth iteration. And what it is that I'm going to be substituting is my 0.7723. What is it that I'm going to be substituting is my 0.7723. Now, you can find after doing a couple of these questions in class today, and come next class. I am not on this because this done. And I really wanted to finish and start something more, but because you never did the homework. But never mind. You'll find that it's the same thing over and over and over and over that you're working with. The only difference is that you're making a different substitution. You're substituting into the original function, substituting into the differential, set it into the interval minus the substituted function over the differential. And you're supposed to be good to go from there. All right. And if you do what it is that you're supposed to be doing, you're good to go. You're good to go. All right. Ay, ay, ay. Okay. Forgive me. My students of the last semester calling me now because them move on to another course and clearly it's giving them problems. So them calling me now to ask me how to help them, but I'm in a class. I ain't answering them. We're doing the fourth iteration. I'm going to be substituting 0.7723. 0.7723. And this is it. My fourth iteration is substituting 0.7723. I'm going to come back to Mr. Raje. 0.7723. Now, when you do this and put this in the calculator, it's going to give you 5.236 times 10 to the negative 3. Please, if you see the question in standard form, do not just write 5.236. Do not write 5.236.
Yes, sir, I remember.
Yeah, man. And there was somebody else, Raj. Now, if you, depending on the calculator you have, if you press S to D, it will convert it to this figure here. So you have to be very careful. I'm telling you the nuances so that you don't go into the exam to get it wrong. These are things that I keep seeing, and students who could get an A end up getting a B because they make a mistake, them cutting it short. They don't want that to happen to you. All right. And then now, when I do this substitution, I'm going to get 3.7893. And as I said before, my general rule of thumb is to use four decimal places or 4 significant figures, right? So 4 decimal places would be my 0.7893 and 4 significant figures. These two zeros are insignificant because this 0 is insignificant. So the first significant figure in this digit here will be 5, then 2, then 3, then 6. I can't use, if you use 4 decimal places, we can have 0.52. That's throwing away too many values. You're going to take a longer time to get to your answer. All right. So as Karna says, the more decimal places you use, is the closer you get to your solution. All right. And when I do that, look at what happens. I get 0.7709. But the question did say to me, round off to the 2 decimal places. Can I stop here now?
Yes, sir.
Yeah, man. Because 7723, when rounded to 2 decimal places, give me 0.77. And 0.7709 rounded to 2 decimal places also gives a 0.77. So once it is that I have the same answer in immediate succession, it means that I've reached the root of my equation. I've reached the root of my equation. That was technically a recap of what it is that we did. And I want to show you something. I just want to show you something. What I don't want you to do. Because if you do it, you're going to be in problems. If you do it, you're going to be in problems. I don't want you to do it. I don't want you to do it. And this is it. Let me show you something here. You notice I went to a fifth iteration to bring to you a point that don't go into the exam go waste time by doing more iteration than you really need to do. Once you see it reach your endpoint, it reach your endpoint. But sir, 0.7709 and then 0.7709, this is a better approximation. If they had asked you for 3 decimal places, yes, you'd have had to do a fifth iteration. And worse if they asked you for 4 decimal places, but the man them said 2. So round off and finish this up and move on to the other question. All right? Now, since I got exactly 0.7709 for both of them, you know that if I'm using 4 decimal places, 0.7709 would be my final answer. Look at what I'm going to do. I am checking. My original function is f of x is equal to x cubed plus 2x minus 2. I'm substituting my 0.7709 into the original function. Look at what I get. I get negative 6.4298171 times 10 to the negative 5. This is what it works out to be in non-standard form, which is really, this sign means approximately. It's approximately equals to 0. So when something is equal to 0, it means that I have found my root. So it is telling me that I have found the root of my question. If when I had substituted, I got a value other than 0, it means that I would not have found the root. Got it?
Yes, sir.
Okay. Any questions?
No, sir. Go ahead, question now.
All right. You don't have to ask 2 times. I'm giving you another one. It says, show that the equation, boom, has a root alpha. All right. Now, don't get confused with alpha. They are only naming what the root is. The root is called alpha. And it falls between what?
1 and 3.
1 and 3. So they're asking to use the Newton-Raphson method, corrected 3 decimal places this time to find the next 3 approximations. Uh-oh. So what iteration are you going to stop at?
The third one.
I hear 2 answers. Which is it?
Fourth one, sir.
The 4th one. Because you have to find the first iteration and it says find the next 3. Right? So you have to find the first. It says it even went as far as said taking 2 as the first approximation x1. So it told you what to use for x1. But if they didn't tell you this, could you find that x1 is 2?
Yes, sir, because between 1 and 3 is 2.
No, sir. We had 1 and 3 equal 4 divided by 2.
Very good. 1 plus 3 is equal to 4, and 4 divided by 2 is equal to 2. So it even give you piece of the solution. All right. So I'm gonna give you no more than 10 minutes. No more than 10 minutes to work this question and tell me what my 3 decimal places are. Thank you. Go ahead, Shanti.
Sir, can you give me a brief recap of what the Newton-Raphson method is? Is it the same as what we're doing just a while ago?
Yeah, man, that's what it is, yeah, man.
So why they name it so?
Because there's 2 people come up with it. 2 people come up with it. Says exactly what I just did a while ago that we're going to be doing now again. So you have to know what the Newton-Raphson method is. All right? 10 minutes, guys. 10 minutes, 10 minutes, starting now.
Sir.
Come on.
Check your chat, please.
Okay, sorry, I didn't realize. And that's what and ooh. All right. Okay, Ashanti, I see your stuff. Just do a quick favor. Just double check the fourth iteration for yours again, please, dearest. And was that your fourth iteration, Alwyn?
No, sir.
All right. Go, continue working, please.
All right.
Just caution your students. You have to be very consistent with the decimal places, because if you decide to do that, your answer is going to be off slightly. All right. So you have to be very consistent, and you'll see me being very consistent with my decimal places. All right.
I'm sorry, can you check my chat for me, please?
So there are 3 students so far that have gotten the correct answer. 3 students so far that have gotten the correct answer. Really proud of you all. The rest of you, please come. One person is pretty close, but slightly off. I'm not going to talk about the answer just yet because I really am forcing the rest of you to do some work. I don't hear some people talk to me from, what's your, all you there, class? I don't even hear you breathe, let alone to contribute to the session. All right, so those of you who are here, you need to participate, please and thanks. All right, 4 persons so far. I'm not hearing from some of the students. Come on, guys, I need to hear from you. Don't let me call you, please. I need to hear from you. 5 more minutes, please. As much as I'm responding to those messages coming to me, I'm yet to hear from a few more students. 1, 2, 3, 4, 5, 6, 7, 8. So I'm waiting for the 8 of you. Thank you.
Sir, you're gone.
Come on, I am responding to the students. Okay, so that was that is your excuse and you're keeping to it, right? By the way, I responded to you, no, I don't ever see it.
Oh, I just saw it, sir.
No, man, I responded, man. All right, very good, though.
Yes, sir.
Mhm. All right, so it's now 6:45. Let me um project for the almost 10 of you that responded to me. Very good. Some of you kind of nearly gave me a little heart attack with your responses. Some of you need to buy LED lights so that you can see well. But for the most part, yes, I am proud of you. I think you are understanding, and I am done with this topic now. What I'm expecting you to do, well, what you should expect of me next class, God's willing, is, and I may, depending on how much time I have, I may just do a quick introduction of it so at least you can see what it is. When I leave Newton Rampson, please do not leave it with me. You must return to practicing it over and over and over so that it sticks with you. Catch a question or two, run through the past papers, sketch a questionnaire to practice it so that it does not leave you. This is some easy 10 marks for you to pick up. All right. So right there, you see, I have my function. I have differentiated the function. And the differential of the function is going to be 3x squared minus 3. My first iteration is 2. It's given, but I could also double check based on the intervals given 1 and 3. 1 plus 3 equals 4. 4 divided by 2 equals 2. You must know the formula. The formulation is not given on the exam. Unfortunately, you're not given a formula sheet on the exam. So you must know the formulation. And then you are going to be handed putting the first iteration rather into the formulation. Remember, x1 is going to be substituted into the original function. It is also going to be substituted into your differential. And when you do that, when you substitute 2 into f of x, you get negative 2, and you substitute it into the differentiated function. 2 squares is 4 times 3 is 12. 12 minus 3 is equals to 9. So you're going to have negative 2 over 9. And you're going to get 0.22222222. But remember, for consistency, Sir Shand uses 4 decimal places. And if 4 decimal places is not sufficient, I use 4 significant figures. Is there a rule of thumb for that? There isn't, but it works. It gives you the answer that you're looking for. If you round off to 1 decimal place or a whole number, you're going to be in problems. And too few decimal places, going to also put in problems. And I don't want to frustrate anybody. And these are some easy marks to pick up, so don't lose it. So to find x3, my x2 value is going to be 2.222. And another 2. And that's exactly what I did. 2 point quadruple 2 into the functions, and these are my output. And then when I substitute it into the formulation, my output is going to be 2.1962 as my third iteration. Now it says for me to do 3 more. So whether or not it come off to the end, them tell me I must do 3 more. So I'm going to follow the instructions and do 3 more, and do a fourth one. So my third iteration is going to be 2.1962. And when I go through that 2.1962 into my function, I'm going to end up with 2.1958. Uh-oh. But I did say the question did say to 3 decimal places. So to 3 decimal places, this is going to be 2.196. And to 3 decimal places, this is the same thing as 2.196. Can you see that?
Yes, sir.
Yes,
Good
sir.
job. So you see that this is 3 decimal places. Alpha. Remember they spoke about alpha? So you're going to continue working with alpha. So them say alpha now is going to be 2.196. All right, so which is exactly what we got for the third and fourth iterations. So did they have to tell you to do 3 iterations, 3 more iterations? They didn't have to. But sir, how would we know? Would you have known that to stop at the 4th iteration, guys?
Yes, sir.
Yes, man, you would have known. You'd have known. All right. Pausing. Are there any questions? Are there any questions?
No,
No,
thanks,
sir.
sir. Just have to go practice some past.
Yeah,
No,
man. That's
sir. I understand.
yeah, man. That's all we need to do. Just yeah, man. Thanks much, Raj. But all we need to do is just to practice. Don't let the something run away from you. If you let it run away from you, you're going to be in problems. If you let it run away from you, it's going to be in problem. You're going to be in problems. Right? So don't let it run away from you. So Let me show you what I want to do. No. I want to look at, come next class, God's willing, I want to look at Maclaren's theorem for approximation with functions that go up to infinite series. And infinite series will be when you're differentiating functions that are negative. Infinite series is, for a finite series, when I give you like x squared plus 2x plus 5, by the time we reach a third differential, they get 0. So it's finite. It's finite. But when you're differentiating functions of this nature, it's going to be infinite. You can differentiate and differentiate and differentiate and differentiate. There's no end because there's no finality with the function. Somebody may say, sir, what do you mean? All right, let me ask you. What is the differential of x squared?
2x, sir.
X.
Oh! What's the differential of x squared?
2x. 2x.
2x. When you differentiate 2x, what you get?
2.
2.
And when you differentiate 2, what you get?
0.
0.
0. Good. So that is finite. It's finite. But when you differentiate something like 2x minus 1 raised to the negative 3 power, that's an infinite series. You differentiate until you full, you still can't done. All tomorrow is still a differentiate and still can't finish. Right? So Maclaren's theorem is going to be involved with these questions. Yes, you can get finite series, but trust me, the exam will never come with a finite series. You're going to get an infinite series to work with. But you'll know when to stop. You will know when to stop because I may say to you up to 5 decimal places. When you reach 5 decimal places, you're done. The differentiation won't finish now because it can go long, go long, go long, go long. But the mere fact that you reach my 5 decimal places, you're good to go. You don't need to, you're not going to get any more points if you give me 8 decimal places because you're just going to waste time in the exam, right? So I can indicate to you when it is that I want my endpoint. Am I clear right there?
Yes, sir.
All right. However, before I move to that point, which is what I wanted to do today, I wanted an opportunity to get that done today, is that I have to move into things like the differential of exponential and logarithmic functions, because when we're doing things like Maclaren's series, oftentimes the function that you get to differentiate is an exponential function. So I have to run through exponential functions, and I also have to run through logarithmic functions, right? The ln x functions, because oftentimes doing the Maclaren's, sometimes, most times, you get the exponential function to differentiate, or you may get the logarithmic function to differentiate, or you may get something that is something different to differentiate. But if you don't know how to, or remember how to differentiate the exponential and the logarithmic functions, you are going to be in problems. So what I'm going to do, God's willing, on Wednesday, we're going to start at 5. I'm going to use about half of an hour to run through a few of these differentials. You know how to differentiate these functions already. I taught you calculus 1. I know I did it, and I know you should know how to do it. I'm going to use about half of an hour to no more than half of an hour to refresh your memories. I'm telling you now because what it is that I'm expecting you to do is to revise the exponential and logarithmic functions in preparation for next class. And then I can spend a greater portion of a class to go through your Maclaren series, show you the nuances like I did with the, hold on a minute, please. Like the nuances that I showed you with the Newton-Raphson, you must know the formulation. So for the Newton-Raphson, you are given a formulation that you must know. Excuse me. You must know because you're not going to get a formula sheet for the Maclaren's theorem. You're going to be needing to know this formulation. You're not going to get a formula sheet. All right. So that's the aim. I'm not spending a lot of time on this because the semester is running and I want to be able to finish and let you guys feel comfortable with the content that is given. All right. Yeah, so I'll end there. Are there any questions?
No, sir.
All right, thank you, sir. All right. Okay, so since there are no questions, not going to belabor it. It's now 3 minutes to 7. I'll give you enough time to go and get a bathroom break for your 7 o'clock class. Have a good one. Thanks for coming out.
Yes, sir.
All right, cool.
All right, sir. Respect.